for another round. This is Mr. Doolin. I thank you so much for tuning in. We're going to jump right into it today. We're going to take a look at limiting reactants. And so first we want to define this sucker. A limiting reactant actually limits the amount of products that can be produced. Now, most of the time it's because it runs out. So, for example, if I'm going to be making peanut butter and jelly sandwiches, I need 2 pieces of bread, some peanut butter, and some jelly. So if I run out of one of those things, right, I run out of bread, I can't make peanut butter and jelly sandwiches because I don't have any bread. And so what we would say in chemistry is that the bread would be the limiting reactant, all right? And so very conceptual is all we're going to do is just look at a reaction. We'll have different amounts of the reactants and we'll ask, hey, which one of those do I have too much? Which one do I have too little of? And that will tell us which one is limiting and which one is in excess. All right, so just to double check and make sure, and I hope that you got that definition down and maybe even that example down in your notes. If you didn't, I suggest that you back up and you get that bent down, because conceptually understand limiting reactant makes the calculations and the types of problems that we're going to run into so much easier because you have a concept in your head to work from. All right, so just to make sure we're all on the same page, if I'm looking at A plus B gives me C, I understand that these are reactants and C is my product, right? And so anytime that we're going to have to do a limiting reactant calculation is if we are ever given 2 reactant amounts. So if I was given like 50 grams of A and 50 grams of B, and then someone said, hey, how many grams of C can I make? Well, it's dependent on which one is going to run out first, because again, the definition of a limiting reactant is it limits the amount of products produced. So I would have to choose which one was limiting in this particular case, all right? And so again, a lot of the times what we're going to do is we're going to use stoichiometry. So conceptually what I would do is I would pick either A or B, and I would do 50 grams of A and I would convert it to grams of B. Now, it can go anything you want to do. You can go back and forth. You pick which one you want to convert to, but we're going to use stoich to convert one to the other, and then I have 3 choices there. I'm going to say either I have too little, which means it's going to be limiting, or I have the exact amount, and in that particular case, it does happen, not very often, but it does happen. I don't actually have a limiting reactant in that case, or I'm going to have too much. And man, make sure you get those things down. So again, the steps and process of this is I'm going to use stoichiometry to convert one to the other, and then at that point, I have 3 choices. Either I have too little, which means it's limiting, I have the exact amount, which means neither one would be limiting, or I have too much, which means it would be excess. All right? Okay. So what I'm going to do now is I'm going to do an example here with you, and I'm just writing a chemical equation up here real quick, and that's AlCl3 plus 3 coppers. And so I've got a reaction here, and what happens in the particular case, if I were to give you, let's make it real this time, I got 50 grams of aluminum mixed with 50 grams of copper 2 chloride. Now, in this particular case, I want to know which one is limiting. Again, I've been given an amount of both reactants. That puts me in limiting reactant land, ladies and gentlemen. Anytime you have, and I'm stressing this is like the 4th, 5th time I've said it, anytime you have an amount of 2 reactants, we are in limiting reactant land, and we're going to do a limiting reactant calculation. So I'm going to convert one to the other. In this particular case, I'm going to choose copper 2 chloride just because, all right? And so I'm going grams A to grams B. I'm going to convert grams of CuCl2 to grams of aluminum. So I'm going to divide this by the formula mass, which is 63.55 grams per mole. And again, we've got a calculator in our hands, so we're feeling pretty nifty. So that's going to give me 0.787 moles of CuCl2. All right? Now I'm going to multiply that by the mole ratio to get it to aluminum. And so that would be 2 over 3. So that's moles of aluminum over moles of CuCl2, and that's going to equal 0.525 moles of aluminum, and then I still need to go times formula mass, so I'm going to do 0.525 times 26.98 grams per mole, and that's going to give me 14.2 grams of aluminum. Now, I made the assumption here that you know how to do the stoichiometry and do a grams A to a grams B. So now remember, what this is telling me is that if I want to react 50 grams of copper 2 chloride, I need 14.2 grams of aluminum to do it. And so this is where those three choices come into play. Do I have too little? Do I have the exact amount? Or do I have too much? So I need 14.2, right? I have 50 grams of aluminum, and so now that answers our question. We have too much. And so in this particular case, we would say aluminum is excess because I have too much of it, and then by default, that means CuCl2 is limiting, and what's going to happen is that the CuCl2 is going to limit the amount of products produced. And so at this point, any calculation that involves converting to a product, like asking how much of a product is produced, how much of this am I going to get theoretically, we would have to use the limiting reactant to do any calculations for the products. All right? So again, all I'm going to do for limiting reactant, it's important to get it down, ladies and gentlemen. How do we know when to do it? You're given an amount of 2 different reactants, right? And I need to know which one of those is limiting. Then convert one to the other, and you're asking those 3 questions. Do I have too much? Do I have too little? Or do I have the exact amount? And that will tell you whether something is limiting or excess, or if they're exactly the same, then you don't actually have a limiting reactant, which again does happen, not very much, but it does happen from time to time, okay? All right, ladies and gentlemen, so it's a pretty simple idea as long as you conceptually understand that peanut butter and jelly at the beginning. Maybe come up with one of your own kind of just general everyday things about what a limiting reactant is so that you can conceptually get your head around it, and it makes it easier once we figure out the stoichiometry. Hey, I'm going to convert one to the other to see how much I need versus how much I have, and then I can ask those 3 questions, all right? So if you do have some questions, make sure you get them down. I'll see you in tutorials for those. Otherwise, I will see you in class.